Okay. So today we're going to go through Unit 15 exercise together. So you have received your marked work. So let's start from the MC part. So for the first one, okay, since a lot of hint has given to you, so most of you have done pretty well. So the first two steps, quite straightforward. You work out the why my pointer is not working. Give me a second. Okay. So for the first one, whenever you are given the volume and also the molarity, you would need to, just like the unit 12, you would need to work out number of mole. Okay, so after work out number of mole, by using the ratio, you could work out which one is a limiting reagent. Okay, so in this case, it would be lead to nitrate. That's a limiting reagent. So based on the total amount of the limiting reagent used in this reaction, and then we could work out that the sodium chloride that's used in this reaction should be twice as many as the lead to nitrate. Okay, so multiply by 2, then that will give you this amount. But remember, this question asks you what's the concentration of the chloride in the mixture. So the remaining chloride in it, because the rest of the used part turned into a solid, a precipitate. So you won't find any used sodium chloride, those chloride in the mixture. So it should be the remaining chloride in the mixture. Okay, so it would be the total amount you add in minus a part that has been used in the reaction. That's a part that left in the mixture. And by working out the concentration, you just use number of mole divided by the volume, which will give you the concentration. Okay, so that's the first one. The second one, okay, again similar. If you are given a question that involves any chemical reactions, okay, so first of all, you need to write out the equation. And again, if you are given the volume, the molarity, you can work out number of mole. And then you will find out the limiting reagent. So for this one, it's calcium chloride, okay, because it's 3 to 2. Okay, so sodium phosphate is in excess. And then this question asks you the number of mole of calcium phosphate. So this one, okay? So by using the limiting reagent we found here, which is calcium chloride. So the one you want to work out become yourself. So that's others. So you divide by others, multiply by yourself. So it will give you total number of calcium phosphate, which is 0.01. Okay? So that's for the second MC. Then the next one, okay, this one, quite a lot of students make mistakes for this one. Okay, so read the question. We have first iron 2 sulfate solution that's mixed up with iron 3 sulfate. Okay, and then what is the concentration of the sulfate ion in the resulting mixture? Okay, so a lot of you have managed to work out the sulfate, a number of mole of sulfate from iron 2 sulfate. So you just need to multiply the molarity by the volume, okay, do the unit conversion. So it should be 0.6 multiplied by 0.05. Okay, and pay attention to the formula. Each iron 2 sulfate formula, unit formula unit will only give you one sulfate ion, but that's not the case for iron 3 sulfate. Okay, you can see a subscript here, 3. Okay, that means for one formula unit, it will release 3 sulfate ion. So when you calculate the number of mole for sulfate ions in iron 3 sulfate solution, you should not only multiply the molarity times its volume, but also multiply by 3. Okay, that's due to the subscript here. So each one formula unit will release 3 sulfate ion. Okay, and then you add them up, divided by the volume, that will give you the concentration. Okay, so quite a lot of students just miss this part, multiply by 3. Okay, so if you have any question or you're not clear about anything, just type in the chat column. I can see it and I will repeat myself. Okay, and then next one, question 10, DSE 2012. This one, okay, so this one gives you the mass, and then it tells you that the volume of the final volume. Okay, so pretty straightforward. From the mass, okay, you could work out number of mole, and if you get the number of mole by divided its volume, then you can work out the molarity, the concentration. Okay, so that's the mass, and then you divide it by a smaller mass, work out number of mole, and then divide it by the volume, which will give you the molarity, the concentration. Okay, and then the next one is about pH. Okay, so for this one, consider the following solutions. Which of the following statement is correct? Okay, let's take a look one by one. A, the pH of Y equals minus log of 0.2. Okay, Y, solution Y is ethanoic acid. So by now you should remember ethanoic acid is a weak acid. Okay, so it cannot completely ionize. So the concentration, although it's monobasic, since it cannot completely ionize, it will only have small amount of hydrogen ions, much less than 0.2 molar. So the pH will be much higher than minus log of 0.2. Okay, so A should be wrong. And then next one, mixing W and Z gives a neutral solution. Take a look what's W. W is 0.2 molar nitric acid, okay, a strong acid. And then we are mixing Z. Z is 0.1 molar sodium hydroxide, a strong alkaline. Okay, so for this one, how do we know, okay, whether the resulting solution is neutral or not? Okay, let's work out. Remember, when we have an acid and base, it will undergo this reaction. Okay, that's neutralization reaction. Okay, so we just need to work out the total amount of hydrogen ion and the total amount of hydroxide ion. Okay, and find out if they are not in the perfect amount, 1-to-1 ratio, then the resulting solution will not be neutral. So take a look for the hydrogen ion, the number of moles should equal to 0.1 times 0.2, so 0.02 mole. And for that solution, number of mole of hydroxide ion will equal to 0.1 times 0.05, which gives you 0.005 mole. Okay, as you can see, not in 1-to-1 ratio. The acid is in excess, so the resulting solution will actually be acidic. Okay, so not a neutral solution. So B is wrong. And then C, the pH of the mixture of W and Z is lower than that of W. Okay, so take a look. W, we have the nitric acid with 0.2 molar. So if we assume it's completely ionized, then the hydrogen ions concentration should be 0.2, right? And then we have X solution, which is hydrochloric acid, again, with 0.2 molar. Okay, so again, strong acid was assumed completely ionization. Then the concentration of hydrogen ion in HCl, again, is 0.2 molar. Okay, so by mixing two solutions of hydrogen ion of 0.2 molar, we didn't change the concentration, okay, of the hydrogen ion, okay, and then it should stay the same, isn't it? Yes. Okay, so for now, so it will be the same, not lower, so that's wrong. So the only correct solution would be only correct statement would be D. Okay, for D, when we have W and X, it's just strong acid with another strong acid. Okay, so it would have a lower pH. But if we're mixing X and Y, a strong acid with a weak acid, okay, so the pH would become higher, okay, due to the weak acid, okay. So that's for question 11. And then next one, for this one, okay, if a sample of sulfuric acid is, the pH is 2.6, then we dilute it with 100 cm³ of water. What will be the resulting mixture's pH? First of all, if we are diluting a sample, we must expect the pH to decrease, isn't it? So for sure, we know C and D is impossible, okay? Because we are diluting a solution, and how come it become more acidic, isn't it? Okay, so of course it's not C and D. And then think about it, A and B. When pH changed by 1, the concentration of hydrogen ion actually changed by 10 times. Okay, so here, if you only dilute it with the same amount of water here, so the pH would not like doubled, right? 5.8 is not reasonable. So without calculating it, you will know the correct answer should be B. Okay, but of course you can calculate the accurate number. So how can we do it? So before we dilute it, we know the pH, so and we know it's a strong acid, so that we can work out the concentration of hydrogen ion. It should be this one, okay, 10 to the power of the minus 2.6. So that's a concentration for hydrogen ion. And then okay, now we're diluting it. Okay, so originally we got 100 cm³. Now we got 200 cm³. Okay, so we just use the number of mole, okay, divided by so because we diluted with the same amount of water, so the concentration will actually just divide by 2. Okay, so divided by 2, that will give you the total concentration. Of course, you can work out the number of mole and then divide by 0.2 dm³. That's also fine. Okay, and then after work out the concentration of hydrogen ion after dilution, and then we just need to take minus log of that concentration, and that will give you the pH value, which is 2.9. Okay, any questions so far?
听不懂。 我想
Yes.
問咧，點解要除2？可唔可以講多次啊？嗰個 sulfuric acid after dilution。
Okay, so originally we got 100 cm cube of that sample, but now we add 100 cm cube of water. So, or you think about it like this. So originally, number of mole would be this number multiplied by its volume, 0.1. Okay, so that will give you this number. Okay, so and after dilution, total number of moles stay the same, right? So the concentration after just become 2.512 times 10 to the power of minus 4 divided by, okay, it should be 200 because 100 plus 100, 200, and then divide by 1,000. So it will be equivalent to this one. And remember, when we do dilution, the formula that you need to remember, C1 V1 equals C2 V2. So the concentration at the beginning multiplied by the concentration multiplied by the volume at the beginning should equal to the concentration after dilution multiplied by the volume after dilution. Okay, so in this case, if we want to work out C2 would become C1 V1 over V2. Right, so C1 is here. V1 0.1 and then V2 would be 0.2, 100 plus 100. Okay. Did I solve your question?
好，明 ，OK。
Okay, okay. Okay, then move on. Next one, which of the following statements is or are correct? Okay, so this one, most of you did it pretty well. The first one, the process of forming hydrogen ion in vinegar is reversible. Vinegar is ethanoic acid. Okay, so it's a weak acid. So it will undergo reversible reaction. Next one, neutralization occurs when sugar is added to vinegar. So we know vinegar is an acid, so neutralization means acid with base. But we know sugar is not a base, okay? So it should not be neutralization reaction. And then the next one, the pH of vinegar used in kitchen is around 1. Okay, so how do you know whether it's 1 or not? Is it roughly pH 1? How can we work it out? Okay, so for ethanoic acid, we say it will partially dissociate, then it will give this. Okay, and because it's a weak acid, we say it's about 1% complete. Okay, only 1% of the ethanoic would go this way to form hydrogen ion. Okay, so if the pH is at 1, okay, if pH is 1, then the hydrogen ion concentration will be 10 to the power of minus 1. Then it will be 0.1 molar. Okay. Then, if it only 1% completes, then we need 10 molar of this ethanoic acid. Okay, just to make 0.1 molar of hydrogen ion. Okay, and remember when we learn acid and base, we say if it's larger than 5 molar, we consider it as concentrated acid. Okay, so would you think that the vinegar we use in our kitchen would be so concentrated to 10 molar? Okay, that's not practical. So 3 again is not correct. Okay, so the only correct statement should be the first one. Then we should choose A. Okay, and the next one, which of the following statement is correct? Okay, so for this one, first one, all aqueous solution contains hydrogen ion. So if it's aqueous solution, that means it will condense water. And water would undergo this reversible reaction to release hydrogen ion and hydroxide ion. So all aqueous solution contains hydrogen ions is correct. And then B, the pH of all acid solution is greater than 0. No, okay? So if we have 10 molar HCl, okay? And if you take the pH, it should be minus log of the hydrogen ion concentration, okay? Then it will become a negative value. So the pH, remember 0 to 14 is a range that we frequently use, but it's not the limit, okay? It can go below 0, it can go beyond 14. And C, all acidic compounds contain hydrogen as their constituent elements. So for this one, remember the two gases that are acidic, carbon dioxide, sulfur dioxide. And the last one, a corrosive hazard warning label must be displayed on all reagent bottles containing acid solution. Yes, a corrosive warning label should be displayed on concentrated acid or alkaline, okay? But for very dilute acid solution, we just need to have an irritant label. That's enough. It's not corrosive, okay? So for very dilute acid solution, no need for corrosive label. Okay, so only A is correct here. So any question for this too? Oh, then I move on, okay? Next one, we have here. Which of the following gases, after dissolving in 1 dm cube of water, will give a solution with the highest pH? So for this one, no need to calculate it, just by looking at the answer, okay? Nitrogen dioxide, sulfur dioxide, HCl, hydrogen chloride. They are all acidic gas. Okay, so only ammonia, which is an alkaline, okay, gas. So when ammonia dissolving water, it will give you a pH higher than 7. So you should choose C. Next one, consider the 4 solutions here. Which of the following represents the solution arranged in increasing order? So from the strongest acid to strongest base. Okay, so acid first. Okay, we have nitric acid and sulfuric acid. They are both strong acid, but for sulfuric acid, it's dibasic. So sulfuric acid will have a higher concentration of hydrogen ion. Hence, it will have the lower pH when compared to W, the nitric acid. So we should start with X and then followed by W. Okay, so we should choose from C and D. Now compare the next two. C is 0.01 molar, Z got 0.1 molar. A strong, they're both potassium hydroxide solution, strong alkaline. So higher concentration means higher concentration of hydroxide ion in the solution. Hence, it will have a higher pH. Okay, so that should give you the highest pH among all four. Hence, you should choose C for this one. And then next one, consider the following statement and choose the best answer. So for this one, the first statement stated that to completely neutralize 1 mole of HCl, the number of moles of ammonia needed is more than the number of moles of potassium hydroxide needed. Okay, so for this one, you need to pay attention. For neutralization reaction, it's just the reaction between hydrogen ion and hydroxide ion. Okay, so it doesn't matter whether it's strong acid or strong alkaline or weak alkaline. It will push the reaction until it's complete, until all the hydroxide have been used up. Okay, so you just need to work out the total amount of hydroxide that needed for neutralizing those hydrogen ion. Okay, so it's not about its strength. The reaction would go to complete. Okay, so for this one, it would require the same number of mole of the weak alkaline ammonia and the strong alkaline potassium hydroxide. Okay, because the number of hydrogen ion stay the same. Okay, same amount of hydroxide ion is required. Second statement, ammonia solution is a weaker alkaline than potassium hydroxide solution. Yeah, that's a fact that you need to remember. Okay, that's all for MC. So any question for MC? And because we only got around 7 minutes left for this meeting, I would like to stop this session here and we start a new one, so that while we go through the structure question, we won't be stopped